The chemical industry has largely been ignored in this fight against climate change.
Catalysts help reduce waste and are therefore green and environmentally friendly.
Does green chemistry use approaches to make new ways of making fuels? Absolutely.
We are integrating AI and robotics to accelerate materials discovery.
Why is this important?
Well, some of the hardest problems that are blocking net zero are very much materials problems, right? The technology we have today is not going to get us there. A lot of the sustainable processes aren't scalable. What we're building here in this lab is actually Marcus, my co-founder, likes to call it a data center for materials, generating, more data than a team of 100 chemists could do. What we really are world leader in is actually using an autonomous lab where we cannot just predict what a material does, but directly actually test it.
Speeding up materials every day that's in an unprecedented pace compared to anyone that's out there.
Many people question, can we do this? Which is fair. But if this works, obviously this is going to change the world. So one of our team members, I don't want to say names, but he believes that scientists might literally be obsolete in 10 years.
Hey folks, today we are in the outskirts of Berlin to visit a company called Dunia AI. They're doing fully automated research for material science. So think AI and robots in labs trying to figure out the next materials needed to pretty much move forward any industry you can think about. Any technological innovation that you know about that's meaningful to your life usually follows up some material science innovation. So the devices you're looking this from, they are possible because of innovation in material science. And Dunia is trying to fully automate this process. And not only that, they're trying to save the planet by doing so. So I don't know, let's get in, let's talk to them and figure out what they're doing in detail. So you guys just follow me. So let's do this.
One of the most exciting applications of AI is actually applying it to scientific discovery, right? If you can actually leverage AI to develop new advanced materials that could fundamentally change the world. The problem is in materials, we don't actually have enough data. So this data problem is really, really severe. Every useful application, text, vision, and even weather forecasting, these AI models are trained on massive amounts of data. The data sets that we deal with in industrial materials research are very, very small. 10 to the power of 3, maybe 10 to the power of 4 if we're lucky. What we're building here in this lab is actually Marcus, my co-founder, likes to call it a data center for materials, generating, more data than a team of 100 chemists could do. And this is then really how we train our AI in an iterative loop, right? It's active learning, so to say. And that's how we can accelerate materials discovery. It usually takes 20, 30 years to get a new material to market. And this is then where really this AI-driven approach comes in. We call it AI-driven autonomous experimentation, right? Because, AI is only as good as the data that you feed it with. And what we really are world leader in is actually using an autonomous lab where we cannot just predict what a material does, but directly actually test it, right? So we design, make, test, and then analyze how materials do behave in real-world industrial processes.
Think about this as the version 1 of this material data center, and what we are building the version 2 over there, that's the proper version. That's just going to be a data server that's just going to be speeding up materials every day. That's in an unprecedented pace compared to anyone that's out there.
This here alone is already 10x the capacity of a typical scientist. Your goal with the next version is 100x.
Yep.
And the next time we meet, you have a big warehouse where it's 1000x at least.
Exactly. The goal and the dream is to be the largest kind of material data producer in the world, unprecedented, essentially 200x. What's the global capacity that there is?
My co-founder, Ahmed, he spent over a year really analyzing the landscape and looking at what it really takes to decarbonize all of these heavy to abate sectors. The one thing that really stood out then was it is the fact that current technology simply isn't good enough, right? Again, why not? It's inefficient materials, especially catalysts. That's the bottleneck to carbon capture and utilization, for hydrogen, for sustainable chemicals, fuels. All of those sectors won't really take off until we figure out this kind of material problem. And catalysts, right? If you don't quite remember your high school chemistry, this is basically the kind of material that accelerates a chemical reaction, right? It really reduces the energy barrier for converting A to B. And in other words, makes impossible reactions possible, right? So the catalyst is really the backbone of the full chemical industry. 90% of chemical processes are driven by catalysis. And with that, actually 30 to 40% of the global GDP depend on them, right? So like, next generation catalysts are really like what we need if we want to get to net zero.
Hydrogen was once predicted to take the world by storm as a major clean energy source. The industry, though, is now facing a reality check.
Well, the problem right now is that while there's a lot of people that want to sell hydrogen, very few companies have actually committed to buy hydrogen because it's still pretty expensive. And one reason why clean hydrogen remains still expensive right now is because electrolyzer, which is the equipment we use to make green hydrogen by water electrolysis, is quite expensive.
This is like the very first version of our platform. What you see over here is essentially it will mix and make like the catalysts, mixing different kind of precursors all together and then heat it up, stir it. Essentially, it's like imagine cooking for chemistry. So you cook like the chemistry, and once that's done, it gets transferred into this module over here. If you go inside, you see a nozzles over there. And what the nozzles does is like it vibrates in a very high frequency and disperse like the chemicals to coat it onto the support itself. And then like from the support, we will essentially sandwich all of these layers together and make an electrolyzers. And electrolyzers fundamentally, it's just like a piece of matter that you see over here. And then we essentially stack it up into a device. And this device itself, it then gets transferred into our testing station over here. Essentially, you have like water that's flowing through. And by applying electricity to it, the electricity would break the water molecules to generate hydrogens and oxygens. Fundamentally, what we are doing is like a lot closer to the industrial applications. So we have like our second station over here, which is doing more scaled up experiments. So the beauty of what we do, like in terms of testing at the device level, is that when you are trying to scale it up, you just need to scale on the X and Y axis. And then after that, you will scale on the Z axis by stacking them up together, and then you increase the total surface area. So all the workstations that I was highlighting it to you earlier are like automated. So we still need like scientists to transfer between each of these workstations. But the second version that we are working on in the other lab that is slightly out of limit is like a fully autonomous system. So with the second version of the platform, the autonomous lab will interface with the AI itself. So the AI will kind of send in like what to execute, and the autonomous lab will execute it and feeds the data back into the AI, and it gets analyzed and the model updates itself. And then the next iteration goes, and it goes through this active learning approach.
And this is room 3, like the new lab that you're building?
Yeah.
And that's like currently off limits for the camera?
All I can do is
Yeah. Dramatic. No, but like we like fully understandable and like we want to respect this.
maybe the most advanced autonomous lab in the world once it's up and running fully.
When will it be up and running?
I think by May.
May,
actually.
yep.
Which one?
May.
Oh shit!
Yep.
Yeah.
That's soon.
Yep.
Cool. Anything else we should quickly look at while we're at it?
Yeah. Oh, let me ask. Elijah.
I feel like the world's worst industrial espionage agent. So
We used to be quite worried about IP and all of that stuff, but I think then actually working in Dunia, what we realized, this is so freaking hard. I wish somebody could actually fix that, Like, we barely managed to,
please do industry espionage.
If you do something very ambitious, right, it's actually very hard for anybody to copy you, right?
I like how you're like, hey, if possible, please steal our stuff and just like let us become customers because this shit is hard as fuck.
Yeah.
One of the most interesting aspects right now about AI is that there's multiple industries where there just isn't any data. You can't just like go to the internet and scrape all of that,
I strongly agree. I mean, I think already today we have like larger data sets than I think like, anything that's available in the public domain, just like proprietary within the right, so DB. And then I think that in the next stage, we're really got to scale it to the world's largest data set, bigger than any industry company currently for. And this is the thing, like for this kind of niche that we found, right? So this first beachhead getting the foot in the door. And then from there, obviously, tiers are everywhere. Then expanding is the natural next.
What's your long-term vision here? Do you imagine that you will sell like basically ASML like big boxes, like put problem here, get solution out here, to customers directly? Will you like build like huge factory sites and like run it for them? Like what's the end game here for you? Like are you more like Nvidia? Are you more like, I don't know, Tesla? Like what's your goal here?
Yeah, I mean, I think like, what we're not doing, right? Like we're not doing software, like, and we're not selling software. That's not the goal. We're not selling hardware either, right? This is our core technology that really kind of globally sets us apart right now. And what really the again is then is like in IP and materials IP, actually like owning what comes out of it, like capturing that value that we've produced with this core technology, right? It's kind of this unfair advantage we have. It's just like being able to go to market much faster.
So your end goal here is to actually discover the materials independently, like maybe with some partners, but like independently, and then own parts of that IP and then license it.
Essentially, that's the goal there. That's the goal there. And then like just doing that, and then nobody has solved that, by the way, right? Like if you can actually do that, like obviously this is massive. So I guess, in a way, ideally we win two Nobel Prizes. The first one probably for automating the scientific method, right? Like, but the second one then really is like solving some really big grand challenges for humanity. One of them being artificial photosynthesis.
I like that. Like in principle, I think nothing is worth doing if you don't earn at least 2 Nobel Prizes. Like one can happen by accident to anybody, yeah, but like 2 is like the minimum standard.
I mean, my PhD advisor is like aiming for 4 right now, so
Perfect. Yeah.
Basically, all three of us have a PhD in some scientific discipline.
Humble brag.
But very different ones, actually. So, Marcus here, like, he's too humble, actually, so I'll brag on his behalf. But he's maybe one of in like 100 people globally that has a PhD in chemical robotics. Right, so like that's a super, super niche field. So he actually built like many different like automated setups that can do chemistry. He also, I mean, this is a bit on a tangent. He also did some chemistry that you can use for computing. Like, he's one of these people where, a lot of things he touches, they just kind of work. I've been a bit jealous, to be honest. Like, I know him since my PhD, and like I was always like, what the is he? Okay, now this is gonna throw that out. But like, a lot of he kind of had this dream that you have as a researcher, right? Like, you have an idea, and then you check if anybody did that before, and then you see nobody did. You go to the lab, you try it out, and it just works. Literally never happens. Like, happened to that guy, and I was like, how? My background is in chem informatics, so that's sort of this intersection of computer science and chemistry. And then Ahmed, he has a lot more gray hair than the two of us. He spent like 12 years in the energy sector, oil and gas. Initially more on the drilling bit, really, like getting oil and gas out of the ground. But then also, with 2 young kids, he said, hey, I want to work on the energy transition, but still at it from the oil and gas perspective, right? So like working for a very large EPC company, looking in all of the different, how they really can make revenue in this net zero world. Like how do they actually profit from that? And he spent a lot of time, like, scouting different technologies, scaling them up. Like, there's a pilot, like a demo plant actually in the port of Rotterdam that he built that converts CO2 into dimethyl ether. And he really came from the industry perspective, right? So like, the two of us more on the technology side, he really came from the industry. He did a lot of BD sales to like really large operating companies. And then, the 3 of us met through the COP26, actually, the climate conference. Maybe that's the first time something useful came out of one of those climate conferences. But actually, that's how the founding team really got together late 2021. And then, I think only 3 months later or so, I think we said, we're gonna do this.
Yep.
Yeah, it was really quick. Like once, I think we kind of came from the technology. He had the problem.
Yeah.
We had the solution, so to say.
I mean, the ideas was developed in parallel.
Yeah. It was 2 different companies in a way, and like they kind of just met at the right time.
One of the interesting things is that it's frequently easier to do something ambitiously big than to do something yet another small. Was it like for you also like this moment where you're like, okay, the moment you said like, okay, this is the goal, actually stuff like started falling a little bit more into place?
Yeah, I think so. I mean, we've been in the space obviously for way before that, right? So like I was working in BSF on digital R&D, right? So like, that was in 2017. So like, this kind of the space we knew. It wasn't that like we randomly decided to do something crazy ambitious for no reason, right? But like we actually knew the problem really well. And then I think like if at all, like we were just, or I was just scared, I think, to try that, I think. But I also had this beautiful ignorance of like, okay, nobody's actually solving this. Like, I was very frustrated with like how in academia you kind of only can push it so far. And like, we had great papers coming out, Nature Chemistry, even some science papers. Like, we did it as good as we could. But, sort of this next leap, I guess you do actually need like a very kind of, driven organization to do that. And I think startups are the best vehicle probably for that. And yeah, I think like as soon as we then put our will to that, I think like, yes, it was surprising how, actually people do get excited about this, right? Like, if you're doing something really ambitious, it's actually much easier to get people to understand that this is something worth doing. If you're doing the work and you need to take the steps towards that, lots of good things happen to you. So I think 3 months later, we did our first little pitch to an audience, and then we immediately won 100K non-dilutive funding, and then I guess that was really the the thing that kickstarted the whole thing. But nobody really questions that we should be doing this, right? So this is clear. I think many people question, can we do this? Which is fair. But if this works, obviously this is going to change the world.
And I think one of the kind of superpower that we have, at least I had, was ignorance. The cliche saying, ignorance is bliss. I always say I quote unquote never had a real job before, so there is no expectation as to what is the norm and what is expected. And I think with that, literally the imagination is the limit, because there's no baseline. You just kind of go for it. And yeah.
What is your recommendation to people in academia in Europe right now that are kind of hey, I would like to take what I do and bring it into a forcing function like a startup? What would be your framework of thinking, your first recommendations?
Yeah.
I mean, it's hard.
Good pitch.
What we tried to do really was kind of first principle thinking as to okay, what's the real problem? What's the real solution? And really think through the problem really well. We didn't actually build any technology, right? We were not per se in love with our approach. In fact, I think Marcus was okay, I need this money, I can build it in 3 months. And I was like, wait on a second, what are we actually trying to solve, right? So, and then we just first talked to customers, right? We were first really trying to find the problem that we're trying to solve, try to understand, what does the solution need to have in order to actually be adopted, and then really build the company from the ground up with that. So start with a really big problem, be really passionate about that. I think that's fundamental. But then maybe not so much okay, in my PhD, I did this small incremental thing, and now I'm trying to build a company out of that. This can work. And, I think there are many examples where people are just so driven about their research, they'll just make it work, which I personally, again, love a lot, right? So I think passion and energy, I think is necessary. I mean, I think our approach was a bit different to that. And it was more okay, what would be valuable? How can we actually really solve a problem that's worth solving? And then really we designed everything from that.
Honestly, don't overthink, just do it. Because the amount of times where we heard people telling us, oh, it cannot be done, it's if we get a cent for every time people say it cannot be done, we wouldn't
wouldn't have needed to fundraise.
No, exactly. and also fundamentally, right, I always say when we first started a bit over 2.5 years ago, people don't understand what we are doing. And now people still don't understand what we are doing. At least they're excited about what we're doing.
I think one of the first people actually we talked to about this, right? He gave us really, really harsh feedback, right? And I think 2 years later, I think both Marcus and Ahmed were why do you want to talk to this guy again? It was such a downer. But I somehow, I think actually awkwardly I get energy when people tell me I can't do something, But then I kind of wanted to actually get just catch up. And now this person actually became an advisor to the company because he's super impressed with how far we've come with how little. And he sees it and he believes it. And I think now he's almost a champion, right? So he really turned somebody fully.
Yeah. Why did you guys move to Berlin to make Dunia?
Berlin has a very, very strong material science ecosystem. In fact, where we are located, it's the synchrotrons. It's a 5 minutes walk from this directions. And then we have all this kind of federal level institute that is just everything is within a minute's walk.
The industrial base is still very strong, right? And I think the proximity to those companies, right? I think that is one of the benefits that we have here.
Our work alone has shown that AI can be used to speed up the time it takes to discover antibiotics.
It takes approximately 10 years and $10 million from the design concept to the market for a single material. And this is a time that we cannot afford.
As AI takes over routine tasks, the role of chemical engineers is evolving.
What's the role of the human here? Is it in the end, you're just replacing everybody and then sayonara, thanks for your help? Or is it more high-level work, or like how do you frame this? How do you justify to your grandmother that you're like replacing human jobs?
So one of our team members, I don't want to say names, but like he believes that scientists might literally be obsolete in 10 years, which I think is a crazy take. I mean, we are hiring obviously like at an absurd rate. So like, we need people, like we need really, really smart, brilliant chemists and scientists that can help us actually design the systems, like kind of perform the research. I think the future will be some kind of robot human team, right? Like, you may be talking to agents, right? Like that help you kind of refine hypotheses, refine research directions more broadly, right?
The role of like the scientist is like framing the problem correctly. So I mean, humans are creative in this way, and then I think someone of the team member was telling me, it's like, oh yeah, maths is easy, like physics is easy if you know what is the problem and if you can frame the problem correctly, and then everything else can be quite trivial.
Which then, funny enough, I think actually raises the bar for like how much knowledge you have to actually put into your own brain, right? Like, like you then being effective with all of these tools, again, like a hypothesis is cheap suddenly, and then not randomly just like trying out lots of stuff, but actually really understanding the problem, really thinking about it, really knowing how to frame it. I think then like it will get very easy to actually, develop new technologies, like bring them to the market as well.
Obviously there will be like jobs that are taken away, but the interesting thing is like once you get like into 10x, 100x speed or capability, bandwidth or whatever, you can also like not only approach the same problem completely different, you can also like approach completely new problems completely different. So there could be quite literally like custom-made materials for any use case directly before the use case happens or something like that. I mean, like not in this generation, not in phase 1 or 2 or 3, but like maybe in phase 4 or 5. And that's like super interesting to me. Always like how it's like really hard to anticipate what like an abundance of like new resources actually enables you to do.
Yeah.
Like from energy to bandwidth to capacity.
Our message when we talk with potential partners, right? Like it's not like we're cutting costs, right? Like we're actually increasing productivity, right? Like you can tackle problems you simply couldn't in the past, right? Like,
removing the bottleneck.
Yes, like I think the role of the individual scientist then will change, right? Like, no scientist can like wake up in the morning and say, I'm going to develop a new catalyst today. I mean, of course, we all wake up and we dream and we hope, but like, this is like a decades-long endeavor, right? But I think like, these things become within reach. And then like, when it comes to material science, right, like sky's the limit, right? Like, they're everywhere. There's so many problems worth solving. And some of them we couldn't even tackle, or like they would take 100 years. So this idea of like taking something that would take 10 years and doing it in 1 year, that's powerful. But like, I think thinking about like doing something that takes 100 years and doing it in 10, I mean, that's kind of crazy when we think about like in 2035 where we're gonna stand with that. So I think the role then of the people will change, and I think like the people that will adopt those technologies, right? Like I think they're then poised to take advantage of that. So I think them outcompeting the ones that kind of get like this kind of digital divide, right? I think that's the real risk for people that get left behind, because it's advancing at a pace where even us, we have a hard time even keeping track of it, right? But then at the same time, right, the individual productivity and the types of things you just couldn't even tackle before. I think that's really where so many opportunities open. Which part of this infinite universe of like scientific opportunities, right? Like, this is some of the beauty, right? Like at any moment you could win a Nobel Prize if you do something really, really smart that nobody thought about.
Maybe afterwards, not today, but like tomorrow I have a little bit of time.
Yeah, no, but I mean, I think this is the thing, right? Like I think the entry barrier for that is going to go down, right? Like, but then I feel like that.
When do you think we will have the first Nobel Prize won by an AI agent?
By an AI agent? I mean, this is the thing, like, who who does what, or like how do you attribute work, right?
So
like,
it's basically the same discussion we had like with professors in universities attributing their name to white papers. You now have like the human attributing their name to the work of the AI agent?
Yes. Yes. I mean, I mean, last year we already won, had the first Nobel Prize, like AlphaFold, right? Like, which was then really for AI researchers in chemistry. I do think most materials, at least to some degree, will be developed, invented with AI in the future, right? I think that's inevitable. I think that's just gonna happen. As of 2025, we have SAF mandates, right? Like, I think Europe has positioned itself as one of the leaders in this energy transition. we do have a really strong industrial base. So I guess like my wish really would be to have an industrial policy that really aligns with the potential that's here on the continent to really like make this next industry revolution, right? Like, we have now, I would say, almost a rare moment, a rare opportunity to really like double down on that, right? Like, let's make it happen. Like, AI for science is like one of the most exciting technologies that's important. What we can do here in Europe is like just like leveraging this industrial base, right? Like, it's not enough to just design a material in silico, right? Like, you really want to get it in the real world. For that, you need a lot of data, like you need a lot of really complex engineering. This is something that we actually know how to do, right? Like, this is something where, like, when it comes to even suppliers and how you're going to solve this tiny part of the puzzle there, these tiny problems we're actually really good at. So I think like bringing that value chain together, like, you have the end customers here, you have the corporates here that can really help you scale those technologies. And yeah, I mean, let's create an environment where it's easy for them to just do their work.